So, I guess without further ado, the topic of today that we're trying to discuss is how do you improve IoT device quality, I guess, leading up to the launch of the product into production and into customer hands, and also afterwards. How do you keep improving it? What do you need to make sure to do? What do you need to kind of put in practice and your processes to make sure that the launch is as successful as possible? Something that's core to us at Memfault and core to the three people who are joining me for the chat today. And so let's pass it over for introductions. I'll just briefly start with myself. I'm Tyler. I'm one of the co-founders of Memfault. I guess we started Memfault back 5.5 years ago or so. I started my firmware engineering career at Pebble, where we built a smartwatch and shipped a couple million devices over the course of, I guess, four or 5 years or so. Continued on to Fitbit, where I met Shiva. I'll let Shiva talk more about Fitbit since he was there for longer as well. Also shipped a bunch of smartwatches. And as I realized and a few others, we kept having to build internal debugging tools. That was kind of why we started Memfault to begin with. Didn't want to build it continuously for my entire career. And so I just do it for one company now. I guess I'll pass it over to you, Shiva, to introduce yourself, since I already kind of introduced you.
Thanks, Tyler. Good morning, good afternoon, good evening. I'm Shiva. I'm a staff embedded software engineer at Google. I came into Google as part of the Fitbit acquisition. At Fitbit, I had the pleasure of working with Tyler and a few of the other great folks at Memfault, and it's been great keeping in touch over the years. Over the years, I've worked on a variety of smartwatch devices. I was the firmware lead on a few of them, and overall, it's just been a really fun career so far. And I'm happy to talk about launching and making sure that everything's, launching with quality today. I think I'll pass it on to Andy.
Thank you so much. I'm excited to be here. Welcome. My name is Andy Cockrell. I'm the VP of Customer Experience at Memfault. And I have been working with our customers, IoT device makers, since my beginnings at Memfault, working with them to help them deploy these devices at scale using Memfault, which is an observability platform, if you're not aware. So this is definitely a topic that's near and dear to my heart, and I'm excited to be talking to you all about it today. And I'll pass it over to Simon.
Yeah, hi there. So Simon Ford, started my career for a long time at ARM, developing things like computer architecture, which you have no choice but to get right, because that's going in silicon. So I did at the V7 Neon architecture, which was sort of early smartphones when we were arguing whether or not people were going to watch videos on their phones. And later on then got involved as we sort of went down to do 32-bit microcontrollers when we were introducing Cortex-M. So really taking 32-bit into the microcontroller space, which was obviously also ridiculous. And work through that, helping deploy that technology, which we'll hopefully get to talk a little bit about. And then as that evolved into sort of building IoT products, we're now building a company focused on enabling the use of Bluetooth Low Energy for cloud-based connectivity. So really getting the cost and size and power consumption of cloud connectivity right down to a level that's, it's going to be adopted into so many different types of product that to give observability and things like that. So yeah, that's me.
Great. Thank you all for the introductions. Definitely better than I could have done. And so now let's get into it, honestly. Simon, I guess the first question is going to be towards you. I guess since you probably, if you were the one who helped introduce Cortex-M, you've been in the industry for longer than most of us. What are the unique challenges of bringing these IoT devices to market? You and now you're the founder of Beacon as well. Can you tell us more about your experience of launching the products, probably from inception to actually releasing them?
Yeah, oh yeah, certainly. I mean, so I think what's interesting is obviously we were launching our own products. So we were launching silicon, we were launching software, we were launching tools, but ultimately we're launching these things that are used by, many, many, many developers. So Cortex-M was about bringing 32-bit into the microcontroller space when kind of the environment was dominated primarily by 8-bit micros and things like that. And then embed was about like driving software, tooling, debugging, just like trying to really push as far software tooling for that space, partly for that product, but also kind of to get the industry to think about the future, because at that phase, you can imagine what the worlds were like, right? People working with 8-bit micros, zip files
Were,
on desktops.
were any
Yeah.
8-bit micros connected to the internet, like at all? Or
Oh,
was
yeah,
that
yeah,
truly
yeah.
the introduction of 32-bit?
No. I mean, it's been going on. It's been going on for years. But I mean, I think, yeah, the exposure we had was, So with the embed stuff, we ended up unlocking those sort of micros for hundreds of thousands of developers. So we saw the whole, spectrum of big companies, small companies, but also, I think most importantly, the maturity of how they were thinking about software. And I think for me, this is the core of the IoT question that you asked. I think people were surprised, or are often, the unique challenge is kind of that people were surprised by the jump in complexity. So I kind of see it as there's two kinds of complexity that people end up dealing with. One which I think we've achieved quite well, and one not so much. The first being just software complexity, right? So a lot of the changes are, it's an embedded, very closed state machine, glorified state machine system that now suddenly has a connection, and that doesn't seem so hard, right? But once you imply a network connection, you imply radio stacks or networking stacks, you imply protocols, but then you imply security, and actually what felt like your glorified state machine system doing, I don't know, motor control or whatever it was doing, suddenly the jump in software complexity is crazy. And because it's wireless, maybe that implies batteries, and batteries implies worrying about sleeping, and things like that, and actually putting micros into low power modes. So I guess, yeah, what we saw, I guess, when we brought in Cortex M, think 7 TDMI in a Philips micro, that's the sort of state of the art. Philips becoming what's NXP now. Yeah, 8-bit, people writing in sort of C and assembler, interpreting data sheets, but also the tooling. The tooling is an IDE with a debug probe. That's the environment someone sat down on a Windows machine, developing, storing code in zip files, things like that. It's not a world conducive to the sort of software complexity you need. So a lot of what we did there was we were pushing, how do you open up debug? How do you get debug chips onto these boards? How do you make the dev boards cheap? And part of that was about accessibility. But secretly, part of it was about enabling things like cheap test farms. So a lot of the push was about how do we get this technology into people's hands, lower the barriers. But it was also about, how do you allow people just plug in a load of dev boards in USB and you have a test farm? You can now start doing CI. You can now start using, things like GitHub were coming around. So although a lot of it was pushing for accessibility, it was also, you deal with software complexity by, starting to do hardware in the loop and stuff like that.
And 100% of companies have hardware in the loop testing, right?
Yeah, they do. I would hope so. Yeah. I mean, we put a lot of effort into that. But I mean, as I say, directly and indirectly, it's amazing when, your compiler is tied to your debugger, is tied to the debug probe, is plugging into an expensive dev board. That just isn't conducive, and one guy writing firmware, saving software in zip files, that's not conducive to a sort of modern, what we would now consider a modern embedded development flow. So I think that bit, hopefully that is now solved. And I would hope most companies are doing that well at some level of maturity, right? But if I looked at the sophisticated companies who are shipping these products, they were looking at the problems beyond that, which is not the problems that you can test in your controlled environment. It's when you put this thing in the real world, how's it going to really react? And I don't think actually the industry's very mature in that phase yet. There's some very sophisticated companies that have been doing it for years, but I don't see that as being very sophisticated yet. And you know, if you think of the state machine analogy, you've just put your connected device in the real world. Basically, you've exposed your state machine well beyond the limits of your constrained device, right? And that's quite unpredictable.
Mhm. These
Yeah,
things are
what
no
was
longer
the
state machines either. So,
exactly? Yeah.
Shiva, you have been working on a fit that probably arguably one of the most complex devices that are running on a Cortex M, at least that I have experienced. These smartwatches have a really nice color display. They have animations. You could probably play videos on these things as well, even though they can't even store them on their actual flash chip because it's probably not enough storage. You have Bluetooth audio. You have an app store. You have everything. Like, how does it all work? How does the sausage get made? Like, do you need to throw a ton of developers at it? Is it truly one person could do it? Is it accessible to smaller companies, I guess?
Yeah, very interesting question. I think it's more accessible than it's ever been. I'd say you probably need more than one developer to do it, but the real key that I've noticed is having someone or the level of support where you can actually understand how to take this MCU that you have and get the most you can out of it, right? Because at the very base level, you know, you can run your basic C code, you can run your algorithms, you can try and optimize it for the architecture that you have, depending on whether you're, you know, what kind of Cortex M processor you have or anything like that. But there's a lot of really cool stuff that kind of lurks at the deeper layers and things that you can say offload to your DMA engine or offload to an accelerator and just get performance pickups that are unbelievable. And when you have a chip that is capable of that and you have the capability to debug it and make sure that you're actually using it correctly and basically, you know, bring all of that into your development process, it really makes a lot more possible. And you start pushing these things to the edge and, you know, getting more and more out of it. And next thing you know, you're running a super complex system on a Cortex M4 or an M33, and it's kind of magical. But yeah, I think it's a compromise and sort of a collaboration between, you know, figuring out what your chip can do and being able to push it to that point and figuring out, you know, at that point, have you locked yourself into that chip and those accelerators, and what does that mean for the chip that you might want to use tomorrow, right? There's always a little bit of a trade-off there.
And it's the other thing that I'm thinking about with trade-offs, and this will be a segue into the next question, is like, you push for more features, you probably have some more bugs. Your devices are going to consume more power. You want those animations, they're going to consume power. You better find a way to like push more to the hardware so that it's more, I guess, more efficient. And it's just like circle basically. But a question to everybody, and I'll start with Andy, is like, how do you decide when you're ready to even deploy a firmware? Like, what is the success criteria in some capacity? What are you looking for? What are customers looking for? You work with a lot of customers. Um, how are they deciding when their firmware is ready to ship to customers, basically, or even their hardware product in general?
That is I'm excited to answer this. I think what we're looking at right now is a lot of customers still really being on the journey of figuring out what great looks like there, you know. We have a lot of folks still going in a little blind when they are at launch. And I'll talk to a lot of you know, give your release manager or VP of support a hug, you know, on release day. There's always a high level of nervousness, right? And I think that's still something we're seeing as a pretty big trend, that people are now very actively trying to move away from. They recognize the cost. And so some of the more sophisticated customers, and really what we're trying to develop across our customer base here, is identifying the right metrics that are going to give you a top level view of what the performance of your device is. You know, if you're B2C, that's going to be, how does the consumer feel about this device? If you're B2B, like, is this going to help make sure that that business can keep their operations going, whatever the device is helping to do. So I think there's really three main categories that are, well, two that are definite across every device, which is going to be a core stability metric that you're looking at And also all these devices are connected, and it's typically the number one thing that people complain about. So that's definitely an area that you want to dive in on. And then if you have a battery life, right? Those are three that are just anyone that we speak to, that's something that they want to know. I would also throw in there a fourth one that we often talk to our customers about, which is looking at a most custom for them, right? Like, what is the most customer impacting moment or service impacting moment on these devices? Often what we recommend do is go to your support teams. They will know what that moment is. And it doesn't have to be firmware related. You know, it can be hardware, it can be anything. But if it's something that we can pick up and give a signal on, that's something that your executives often want to look at as well. So I think having all of these measurements in place and having some sort of like what is good enough for the product delivery, right? Like have some sort of level of excellence of, we want our product to be able to perform at this standard because that's what good looks like in this industry. You know, for example, that customer impacting moment might be, we work with a lot of audio companies, right? And just looking at stability, connectivity, and battery doesn't necessarily check all the boxes for them, because the key thing for these audio companies is audio dropouts. That's very, very noticeable for a customer. And so having those 4 different metrics that you're looking at, and having a bar that you have to hit, right? And once you have that bar, now you can be data driven, right? You know if you're release ready. And that's when you can feel really confident, and you don't have to go over to your release manager. You don't have to go to your VP of support and say like, good luck. I know you can't sleep this week. You guys know, you already know. It feels you can ship with a lot more confidence, right? So I think that's really where I think that you need to be investing, is figuring out what good looks like and measuring it, right? It's not a complicated topic, but it's complicated to do.
Oh, great. Thank you. And I'm going to pass it to Simon and Shiva, because I want to know, we call them go or no go metrics at previous companies. And so I'm curious, like, Simon, what are your go and no go metrics? Like what are 2 to 5? I don't know how many you're actually measuring, you know, what are yours?
Well, okay. So, yeah, I mean, there's definitely like go, no go metrics you can measure and things like that. But if I'm honest, like the go, no go metric, sort of leading on from what Andy said, is have you got confidence that the team would spot something going wrong that they're looking for? But also, have they got confidence that they could spot something going wrong that they're not looking for? So I know that's not a specific metric, but as you know, because it can be somewhat, you know, this is why you're talking about, you know, battery life, or you know, if the device is crashing. For me, those are great examples of smell tests, that they're not telling you what's wrong, but they're telling you that something is wrong. So they might be the thing that gives you the cue to go and investigate. And I think that's where a lot of you know, that opens up a lot of opportunities if you're given the reason to go and look. You know, the investigation is what actually finds out what the problem is. But what are those key things that that you know, you can smell something's off. You don't know what it is yet. Might even be a hardware problem. But if you know what, a device crashing, that could be caused by so many different things. But if you distill it down, many problems end up with a device crashing, or they end up with, well, why is my battery draining quicker than I was expecting? That's something's up. I don't know what it is. Is it sleep cycles? Is it intermittent connectivity? What is it? I don't know. But yeah, for me, it's that is the team confident that they have the visibility that they need to spot what they're not expecting?
You're almost talking about like the core, almost the root thing that you need even before shipping a product, is you need a pipeline. You need a way to get the data. And even if that is like, you have a button on the device that's like a contact support, you get to email Simon directly to tell them what is wrong with his product.
I don't know. I don't think I'm recommending that. No.
but that's truly the first step. Like, even before you have a metric, it's just like the ability to know that something is going wrong.
Exactly. And building that into the culture of the way the team is thinking as well. So, I mean, that can be through the development cycle as well. But for me, that's what gives you confidence, right? Because the team is thinking in the right way, and that means that, you know, they know what they know what they might not know. For me, that's the sort of thing. I suspect Shiv's probably got some good,
Yeah.
very specific ones for you though.
I know Shiv has been in the room. So Shiva, what
Yes, exactly.
what were your go and no go metrics that you decided on at Fitbit and maybe Google?
Yeah, so there were definitely many, and it ranged from, everything that Simon and Andy have talked about. You're talking stability, battery life, and everything. The one that is always, always, always top of mind though is, can you successfully firmware update, right? You release your firmware, you're out in the field, and you find something. The first thing you want to know is, hey, do I have confidence that I can get this update out there and that it will be successful, and that if there's something that's affecting, whether it's B2C, B2B, like, can I get this out there and get a fix out? So that one was always the most dramatic one. What's the difference between 99% and 99.5%? Turns out when you have a lot of devices out there, that's a pretty big difference in terms of, say, customer support calls or anything like that. And beyond that, like, I don't think I can explain it any better than Andy and Simon did. Like, you want, like Simon said, you want to have things that you can make sure you have the visibility. You want to, know that you can know if something's wrong and know if something regressed, and whether you can dive in on that at a population level and see, hey, who is this affecting? Like, I might only have 1,000 people calling into customer support, but if this is affecting my entire user base, that's a big problem. You want to be able to sort of isolate those things and say, hey, is GPS only going wrong in South America? That's, something that you really need to know. And so, yeah, having those metrics and being able to drill down on those is really, really important. And, one thing that I always thinking about is, Tyler, you wrote an Interrupt blog post called Counting Crashes to Improve Device Reliability. And one thing that I think I commented on that article is, you want to definitely have your statistics. You want to know, like Andy said, you want to know what you're measuring, first of all. And I think it's just as important to assign meaning to what you're measuring, right? Because I've seen it where it's like, yes, we are aiming for 14 days between crashes, 21 days between crashes, but that's all kind of arbitrary numbers unless you actually have an impact behind it, right? Like, is it 21 days between crashes that actually matters to us, to our customers? Or is it, how many of those crashes did they see? Or what is the actual impact of it? Does frequent reboots drain your battery? Yeah, usually it does. So yeah.
Yeah, I think that's a great point. And it goes like very well into the, you have these things that you want to measure that is giving you a pulse on, like, is the device sort of all of the essential pieces of the device operating as it should? But ultimately, these devices, especially if it's in the hands of a consumer, like if we're talking about consumer electronics, like, or really, I don't know why I said that, it's any product, like the product has a purpose, right? Is it able to fulfill the purpose in the way that it was designed, or is there something that's malfunctioning that's not enabling that? I think battery life is a great example that you brought up. We have a lot of devices that people interact with in their day-to-day. Wearables is a great example of that, where you don't want to have to charge it halfway through the day. A lot of them are specifically timed so that you can take it off and charge it while you're sleeping. A lot want to be capturing data at night as well. So it's a very important thing to make sure that you are aware that the product is operating as intentionally designed, right? So that you don't have, I was literally talking to coworkers today about the frustration of something running out at 10 a.m. with the expectation that it's going to last all day. And they're measuring their workout and getting points. They're in this competition, and all of that now is lost for the customer. So any of this goodness that other teams might be working on to incentivize behavior, create quality around product, all of it really relies on the basic functionality of the feature and the basic performance standards that products also like set out for that device as well.
Simply put, if you're building a lock and it doesn't unlock when the user wants it to, that's the core functionality that's not functioning, right? Or if this temperature sensor has to track temperature every minute and it misses a couple minutes, it's a core metric. If that's getting worse or better, that's a problem that you need to go seek out. Yeah, Shiva, I'm going to pass it back to you for another question. So we're going to dig a little deeper into a bit technical. That was a high level conversation. This is like, we're in development. We're building an IoT device. We want to ship it. Maybe it's in 3 months, 6 months, 12 months, depending on how complex the device is, honestly. what are developers doing? What should they keep in mind? What should they build out to make sure that they have? Of course, you said firmware update. There needs to be some process in which you get information back. But what else are developers doing? What's the best bang for the buck? What should they be doing?
Yeah. So there's two main points I'll make here, and then I'd love to hear from the group as well. The first one I would say is not treating development and shipping as two different things. And I think it's very easy to fall into that trap. You're so hyper focused on developing and making sure the features are in and making sure they're bug free. And then by the time you get to production, you sort of have to mindset shift into, okay, how am I monitoring this? How am I going to make sure this all works when it's out in the field? And you really need to be thinking about that while you're developing, right? You can try and make sure that on your debugger that the feature works as well as possible. But at the end of the day, your customers or other users are not going to have a debugger. And so you need to make sure that you can monitor and test that stuff while it's in progress. The other thing is you want to make sure that you have a culture of, very honest testing and stress testing of that device, whatever you're making, while you are developing it. So even if it is a point where it doesn't do much, you're just sort of wearing the device and, hoping that it doesn't crash, but maybe those metrics are already getting reported back to a central location. You want to make sure that people are doing that, because that's going to be your earliest indication of whether things might be going wrong, what you might need to focus on, and sort of getting you in that mindset of, hey, this thing might already be out. Like, let me imagine that it is and hope that I can start getting those metrics and get everyone in that mindset already before we actually have to launch. So those are the two things that have really, come to my mind or top of mind over the years, but I'd love to hear what the others think.
I have a quick add-on to that. I think that's a fantastic point, and an observation I've seen across a lot of customers we've worked with is that you're developing multiple things, right, in parallel. And one of those things is also going to be the data path, or getting the cloud element, or whatever data path you're working with. Maybe there's a hub that you're hopping through. You're hopping through some iOS or Android app. One thing that we really see is in order to actually pressure test these systems of monitoring and being able to have very fast development in things like beta, you need to have those pieces of connectivity in place before beta. And this is a step that a lot of people, I think, miss the landing on the timing with, where they ship their devices out to the field, they're in beta, but they don't have the hub set up, they don't have the app set up, they don't have a connectivity path, or maybe even potential for OTA, and the way that they're retrieving their data is not this very not the way that they're going to be doing it once the devices are out in the field. It may not be with the same metrics. It may not be looking at the same, clear KPIs or framework for debugging and identifying issues. And this is such a key moment where your team has the ability to see what's going on while they're trying to rapidly iterate and practice using the tools. And to Simon's point as well, if we are collecting a high level metric on connectivity, and that's a key problem, let's start measuring all the things that are going to be impacting connectivity, so that when it's in the field, we feel like we have all those tools set in place as well. So I really do think this is a place where it's like a program management issue of making sure that the connectivity is set up so that you can use all these tools and really accelerate your development.
Yeah, well, one thing that I think it's interesting to look at is, what are the tools you need near the end, right? So imagine your system is deployed. What are the tools you need at the end? What are you going to be looking for? Accelerate that, bring it right to the start. So it's just part of what you're doing. But the other thing is, potentially during these different phases, you are looking for very different things. You're solving very different problems. On the bench, you're solving certain problems. In the early trials, you're quickly iterating to try and get out bugs. Later on, you're making quite hard decisions about, should I even fix this bug? Is the upside worth the risk? Or is, as you were saying earlier, is this even affecting a lot of people? So engineering might feel horrible that there's a bug there, but it's not infecting enough people that it's worth allocating time to. So there's all these different questions you're going to have through the life cycle of the product. But if you can distill that down to, well, it's the same set of tools or the same set of parameters that we can use, maybe in different ways at each time, that's really powerful. So yeah, thinking, you know, what's the tool that would allow me to answer questions, or what's the mechanism that would allow me to answer questions at different phases? Can I sort of consolidate things so that we're integrating sort of concepts or processes or whatever that have real value all the way through that cycle? And then you can invest more in them, which is awesome, right? That's, the team can really get behind them and things like that. So for me, that's really interesting. Like, you know, not thinking them as distinct phases, but like how you know, the different questions you can answer with kind of the same tools, I suppose, the same questions you're asking of your system.
I've always thought throughout development, you're building a bunch of small little products. Your dev board is one product. Like literally, it's a different rev. You need to make it good. Your customers or yourself, you need to make it good enough for you to use that. Then, obviously, your end product is very different. It's sealed. It has no debug ports probably. But even along the way, Andy was saying, like, you need to test your connectivity. You need to find a way to get a data path, but you're not going to have the hub and everything built. You're building all these things. You're flying the plane while you're building it. I've always tried to be as pragmatic as possible, as building in the hacks along the way. With Memfault, you can integrate Memfault day one, and you can extract the data via the serial port, dump it to a file, and like upload it to our website. Like literally dump ASCII text to our web server. It's amazing. Don't use it in production, but it's a great way to hack around it. And I think my favorite example is, no naming names. We talked to a customer years and years and years ago. They could only debug their devices through LTE because they built immediately the final production data path and never built the hack to just get a log via a serial port. Pretty wild, but I think you're building small little products and iterations along the way. Okay, moving along. What else do we have? We've talked about getting the data into a system. Just a pretty quick thing, like, what does that actually mean? Does that mean a database? Does this mean a file on your computer? Who's getting the data? I guess I'll go to Andy, because you actually probably are dealing with this. Who's actually getting the data? Is it in a database? Is it just a person reporting? Is it Memfault? Is it a bunch of custom tools? What are people expecting to build?
Yeah, I mean, you know, Memfault, our hope is that we're simplifying this, right? Like, we see this as a huge pain point across a lot of people who we're talking to. So, you know, you'd be surprised at the percentage of customers or the percentage of firmware engineers that we talk to on a day-to-day who, even like the folks who have the sophisticated tooling, the folks that have the data, the folks who have that, it seems to always end up living in these pockets that you have to query and find and treasure hunt and get to the right information. And so I think that it's been I don't think that there's a one size fits all. I think everyone's trying to make it up as they go along. And it's a big pain point for them. So this lives in data lakes. It's queryable. Sometimes it's in a BI tool. Oftentimes what we find is that information or data coming from devices is not something that data scientists are particularly familiar with, and they have a really hard time figuring out like what's the right way to frame this data so that it answers the question you're really trying to answer, right? And then this data, oftentimes we'll see like a product manager, or even like a VP or someone just trying to get this dashboard or graph that they need from this like huge amount of data that they've collected. And so I think that's kind of like the status quo of people who are saying, hey, we are collecting telemetry, like we have this data, it's so great. Obviously there are people who are like really making investments here, but oftentimes these teams get overlooked for resourcing as well, which can be another whole slew of problems that you might be running into. So I think I think everyone's dream is like a unified single source of truth where you can really trust the information coming in. That seems to be another theme that we see, that people are like, oh, but it's like a device, like this is out in the field. What exactly is the measurement that's coming in? Is it aggregated appropriately? Does it make sense? Are we looking at it? Are we comparing it and slicing it by all the different SKUs. We have international customers and they have different plugs, and we're selling over here, and we have 4 different suppliers and multiple different software versions. And I just need to know if things look good or not, like this can actually be a very, very difficult problem for folks. So it's really exciting to work with them on getting all of that information, very easy to understand, collecting the right metrics, and having a very easy creation of a graph or chart. Like that's what a firmware engineering team needs, is not to outsource this data to like a BI team, unless you have a very sophisticated, well-resourced system. Like a lot of us don't. And so being able to just be able to have that at the ends of your fingertips, ready to go if you need to answer a question on this like panic Mayday support ticket that just came in that's like stressing you out. You don't want to add to like a 2-week wait time to get that information, right? So I do think that it's a huge problem for companies of having the right data in the right place at the right time to move quickly and efficiently.
Get the data before you think you need it, at least somewhere. Awesome. So this is a question for Simon initially. Now we have the data. We also have customer feedback. Consumer products probably have reviews on some sort of system. You also have executives saying things don't work. Why is this broken? How are you prioritizing all of these fixes? How are you prioritizing, I guess, the bugs and the behavior, and also developing new features? It's honestly a lot to deal with.
Yeah, and again, it probably depends on the phase of, the rollout
Development.
or whatever, or even, to be honest, the type of company. But yeah, I mean, I think generally,
how should people think about it? Yeah.
Right. Yeah. Different. So how do people think about it? Well, I think certainly what I see a lot is customers do get the attention, right? So it's very clear if a customer is complaining, everyone knows about it, especially if they're an important customer. Obviously some companies, they deal with a small number of very important customers, others deal with very large quantities. But in general, I think, the default is the customer gets the attention. And they complain about things, or they ask for the features they need if you're trying to sell to new people. But the joy of having metrics and data is you can start to make much better decisions, right? You can start to balance this. I think, as Shiva was saying earlier, like is this a standalone customer? Is this just the noisy customer I've heard first, or I'm hearing like an iceberg at the tip of the iceberg of there's a lot. I can go and look in the data. I can understand. I can start to make more intelligent decisions, about that. So I think whilst companies without this data available to them, they're just being driven by customers. That's what we see, right?
Customers and anecdotes. Yeah.
Yeah, exactly. Yeah, all that sort of thing. But I think what's really interesting, and also actually product analytics is interesting to us, right? Part of what we're doing with Beacon, right? It's, how do you get a cheap data channel? Part of that is for engineering diagnostics, like the sort of stuff you guys do. This is why we love Memfault. Works beautifully in what we're doing. But part of it is product analytics. How is someone actually using your product? They're not talking to you, but they're using it in a certain way, or they're not using it in a certain way. They're using it in different ways. So it's not just engineering diagnostics. It's product analytics, marketing analytics, things like that. That can help you really understand, is what you're hearing matching? When someone's saying a feature doesn't work, is it actually a feature that's significant, getting used a lot, etc.? But for me, the exciting one about data is actually what I would call the hidden problems. These are the ones that don't get any attention always. And data can really help there, right? So this is the crashes that no one reports because actually rebooting it was fine, or it taking multiple times to connect. It didn't hurt. It's hurting your brand. Your customer is losing trust in your product, but it's not over that threshold. Those can be really important. But then the killer hidden problems that no one's even telling you is, your battery is draining at 3 times the rate than you thought. No customer is going to tell you that's a problem because this thing's meant to last for 3 years and it's fine, right? Everything's fine. But actually, if you didn't know that your battery, for whatever reason, is draining at 3-4 times the rate you thought, you've got a time bomb on your hands. And then you're going to have a lot of very upset customers in a year, right? And some of this is fixable. You fix it in software, you do whatever. Maybe it's a recall. Maybe you can, how you respond is obviously dependent on the problem. But for me, yeah, those hidden problems that the customers don't even know they have a problem yet. That for me is like, that's the total other end of the spectrum. And I mean, that's the sort of thing that can kill a company, right?
Yep.
I was,
Go ahead, Andy.
I've thrown around the little bit more conservative statistic that I've read, which is 30% of customers who experience a problem call in. And I was told off that it's actually closer to 8%.
So that feels high.
I try to be conservative when I'm talking to folks. But it's also, and it goes back to what you're saying, Simon, is like the deadly piece there. The most dangerous piece is the passive dissenters, right? Like the people who are unhappy, but they don't say anything to you, right? Those are the people who go on to Reddit. Those are the people who decide to terminate the contract without talking to you. Those are the people who tell, their friend wants to go purchase something at some business and they're like, oh, you use this, right? How is it going? Oh, it's terrible. Depending on if it's a consumer or it could be tons of people who feel this way, or even just one bad referral of a substantial larger B2B customer could really be highly impactful for a company. And so if you don't know this, I love the concept of thinking, the point around the lifetime battery. That's a huge problem for people, especially if you have, we're talking about hundreds of thousands of devices. Okay, now you thought they would last 3 years, 1 year, that's a huge cost and risk. So I just wanted to underscore it's like the silent killer, that we need to be avoiding.
Yeah, all of this certainly resonates with me. I've certainly even seen those killer bugs before where, it's not used by a huge amount of your user base, but turns out if you use it, then you might eventually fill up your storage and never be able to recover the device. Yeah, you definitely want some observability on that. You want to make sure that it's all working. And, just to kind of underscore the point that Simon made, you do have a good amount of squeaky wheels in the process of development and testing, even internal testing. And you have to make sure that you're balancing how you are taking in those bug reports, how the information is getting to you, and how you are triaging it, right? Like there might be one person that saw that bug that's going to kill the entire watch in 2 months. And you have to make sure to take that just as seriously as everyone who's saying, hey, I started an exercise and the device crashed after 5 minutes. Like both of them are very important in completely different ways, and one's way more visible than the other. But you have to make sure that that is, getting it's the attention that it needs, and you want to make sure that you're watching for it.
Yeah, awesome input, everybody. We're gonna try to go to questions pretty quickly, but I do want to do a quick round robin for let's just kind of gate it around. You're about to launch to production. One tip that you want to tell the attendees here, they should make sure to either track or to do or to make sure is in place before they ship their device to 1,000, 10,000 people, basically like in the next month or so. I'll go with Simon first since you're already unmuted.
Oh, okay. Well, yeah. So for me, it's the early warning test one, right? So I learned this actually from a different domain. It was Amazon, whether it's folklore or real, I don't know. But they measure cash going through their register, right? And if at any point, any second, because you can imagine the scale it's at, it drops, there's something wrong, right? And it could be someone just pushed a CSS change that meant that the button for the credit card payment thing didn't render. Or it could be, some JavaScript. It could be the payment gateway in some country is not working anymore. It could be anything, right? But it's so fundamental that they identified this thing that's the smell test. So for me, yeah, that's my number one. What's the smell test that makes everyone look? You don't know what the answer is. It's not telling you the answer, but it's telling you to look and look quickly. Yeah.
Got it. Andy, since you're unmuted as well.
Shoot, he took mine. I'm such a believer. I'm such a believer in it. Like these devices are so complex. I really think that you need to just like hone in on a signal, right? Like that one signal, you need to just be able to look at it and know like good, bad. You need something very easy to look at because it is unmanageable for you to look at all of the different things that could be going wrong, right? You need a starting point and you need to know, do I need to go down the rabbit hole today or are things going smoothly, right? And I think it's important for just, talking about the reliability of the device, de-risking a product launch, but also these teams, when you zoom out, they are so strapped for resources. You need to know where to deploy your resources. You can't just have people sitting and monitoring all day long. You need to be able to also have that indication of good, bad, like work on new development of this other product line, whatever it is, or you need to be focused on this right now.
But so one thing you just said there, just made me think of another thing, which is if you have these metrics or this metric or whatever it is, it's something that the whole team can agree on, right up to senior management. And often it's a senior management, it might be in another situation, it's an engineer who just is shouting, this is important, but because no one has agreed what important looks like, it's very hard to move the machine and suddenly make that intervention and stop what's working, allocate the resources. But if the whole, if everyone in the team through senior management down knows that this is important and everyone's agreed why it's important, then the organization can respond. And often we see the reason people fail is not that, something is not understood. It's that the organization can't respond. It's not the technical engineering of a debugging problem. It's fundamentally the agility of the organization. So I think that's important.
Yeah, I'll take a slightly different tactic here. And it's kind of related to something Andy was talking about. I would say make sure that your team's mental health is being watched. Because, especially when you've had your team working on this for months or maybe years, and, it's about to go out the door and all you're hearing is the negatives, the bugs, the potential stability issues, it's really disheartening. And you want to make sure that that team is staying motivated and that they are, just basically able to function at the best they can. And that, you're not all focused on, oh, everything sucks and everything is negative and, let's fix it and pull all the long hours we need to. I'd say keeping your team's mental health in check is very important during that stage, especially.
The amount of customer support tickets will never go down if you're successful. It will only go up because the number of devices.
What you just said actually also is that management problem often, right? If everyone's agreed what good looks like, a lot of stress comes from mismatch of understanding of the state of play of things, right? And often the people who know but aren't being listened to are the people who are going to have to deal with the problem. So yeah, anyway, Memfault is a mental health tool. Yeah, interesting.
Some have said that. Okay, we are going to jump into a few questions, and then just before the hour, I'll basically wrap it up, and afterwards we'll probably continue on with some more questions. And so if you're in the audience, please ask them, but we're going to churn through some of these. First one, it was actually short and sweet, and I really liked it. How important has dog fooding been in your experience, Shiva?
Oh, it's been the most important thing for testing beforehand, because especially, not everyone who's dog fooding your product is going to be an engineer, right? And you want to know, how all kinds of people are going to be using these things. Like, me as someone who's worked directly on the product, yeah, I might know where the problems are, but that might mean that I have blind spots and I'm not testing something. I also think it's very important to have people who are very close and, familiar with how the product works to give you those like really detailed bug reports. I think all your dog fooders should know how to write proper bugs. And I've certainly seen instances where people are accepted as dog fooders and then don't know how to, give a proper bug report. So I think that's very underappreciated. But yeah, honestly, it's one of the best ways to get visibility before you launch the product. And it's one of those ways to make sure that if you are working on that pipeline to get analytics or any kind of data, that's the best way to test it out before you have to, act before it's prime time.
Yeah, we would have never ever gotten a firmware update out without extensive dog fooding at Pebble, truly. And expanded with it. Cool. I guess going to see you, Simon, because this is so relevant to you. And you integrate them in Vault. Some SoCs are very limited on flash space, program space, RAM space. How are you collecting any data? Like storing metrics is kind of expensive. Storing a record dump takes a lot. Like, we're in microcontroller world. Can you capture that much data?
So explain the question, sorry.
I think people, when they think of capturing a bunch of data from microcontrollers, it just it's JSON payloads, but it's actually not. You're just capturing, I guess, how small of a footprint can you actually be to capture a bunch of this data?
For Memfault specifically, is this? Or,
No, just in general. I think just in general. I think just like creative. I mean, for Memfault specifically, I would just say it's like 5K of code space and a couple K of RAM. But I guess, is any device too small to capture diagnostic data? Should it ever be allowed? You know, is the code space worth it for diagnostic data? Maybe that's what I'm getting at.
Right. Yeah, I mean, yeah. So it's obviously yeah, it's an interesting question because it's quite open ended, but yeah, I mean, so many things you can distill down to a small amount of data, I guess, yeah. So I think, you know, even on this smallest of devices, I mean, so we're working in the Bluetooth space, right? Bluetooth low energy, tiny chips, really low cost. The reason that's exciting is because actually it's a cheap channel that means you can get diagnostics out, you can get product analytics out. So this really can go down to the tiniest of devices, and yeah, I would explicitly exclude it rather than assume you can't do it. I mean, you may have to be clever, you may have to distill data down to very small amounts of data, which is actually your state, which you're going to propagate or whatever. But yeah, I mean, I think assuming that you can't do it is not the right starting position anymore. Maybe it was a while back, but I don't think that's, especially if you've got some sort of connectivity in there already. Yeah, I think that's the wrong starting point. You should be thinking, this is possible. What are the constraints I need to put on myself to make it viable for the price point I'm trying to hit for my product?
Yeah, we see people ask that a lot. And also with like, there's concerns about space, about performance, all that jazz. And I think looking at products that are being developed today, right? Like you're talking about, we're able to get it into a very, very small space with very, very, very minimal impact on performance. And what is the trade-off of doing that versus not knowing, right? Like, you know that you could have this very small impact and bake it in from the beginning and mitigate all these risks that we've already discussed in this call, right? So I violently agree with you, Simon. It's like you have to really want to try to figure out why you're not going to be doing this or why it's impossible to do this, because I think it's definitely the wrong way around to think of, you know, observability and monitoring as performance degradation when the whole point is to resolve issues you know are impacting your performance at scale, right?
Yeah, I mean, I might now, thinking about it, I might answer it in a different way, which is, based on what you're saying, what is the cost? Let's say you're, and we see this so much, people over-optimizing their hardware choice, you know, really squeezing RAM, really squeezing flash, and for some reason, some engineer, often perhaps isn't that experienced, has made some trade-off that they believe this microcontroller and really squeezing the RAM and flash is the right thing to do because look how much it saves. But that's often not seeing it's quite a unsophisticated way of thinking about cost, because you know, cost of deployment, cost of intelligence, or cost of ability to even develop the product quickly. There's all these sort of NRE type costs that often that can impact. So even at the NRE level, it can have a massive impact to under-specify your processor, let's say. And that's not when you're getting to the point of, well, how much does it cost to deploy? What does a recall cost? What does so I think, and I mean, I don't know why engineers do this, but they're very, very conscious of the cost of the individual chip, maybe looking on DigiKey, and very unconscious of the cost of their time. the cost of deploying a product, the cost of if something goes wrong, the cost to the brand. So that seems a perpetual problem, you know. And all I would encourage, yeah, is exactly like, you know, how do you do your cost analysis at a wider scale, and then I think things become very clear. Or go and talk to people who've made mistake before. That's another one.
Got it. Okay, I'm gonna basically wrap up here in case people have to leave in 2 minutes at the hour, and then we're gonna come back to this conversation. Give me 1 second. Share my screen. So yes, so please stay. We'll do more Q&A. We probably have some more horror stories to disclose as well and share with you all. But we'll probably stay about an extra 15 minutes or so. But just want to wrap things up. Thank you all. These are the panelists. This is how you'll get in contact with everybody. And so we have Tyler, Shiva, Andy, and Simon. These are their LinkedIn URLs, basically. Please reach out to them if you have any questions or want to connect with them. They'd be more than happy to chat. I got confirmation from beforehand. And then me and Shiva write on Interrupt all the time, or we're writing on Interrupt all the time, and check us out there. We just want to mention a couple more things. Upcoming events for Memfault. We have a webinar coming up on March 12th. Definitely try to attend that. It's with Francois, our CEO at Memfault. A lot of kind of thoughts on basically a lot of the stuff Andy talked about: connectivity, battery life, stability, and what we're trying to do at Memfault in the basically the short term and in the long term. And then also we'll be at Embedded World. If you all are at Embedded World, come find our booth. We'll have a lot of our team there. I will unfortunately not be there, but a lot of other people will be there as well. And so please find us at Embedded World. And if that's it, that's it. Thank you. But let's go back to questions and continue onwards. So keep the questions coming. Get out of this. I had one more comment to go to the last thing. I just wanted to get it out. We have so many customers that want to extend their flash part after integrating Memfault because they realized they made a mistake and didn't have their flash part big enough to store the full core dump or store enough metrics, which I thought was interesting. And yeah, no one values their time. So in terms of like the amount of time I had to say, the amount of time I had to spend trying to save code space was wild. It's just not fun. Okay, let's continue with some questions. Let's do Shiva. Agile. Does it work in hardware development? Does it work in firmware development? Dispel some rumors for us.
That's a big responsibility you just gave me. Yeah, so
mainly around post-production, I would say. So like once the device is shipped, can you work in an agile environment?
Yeah, in fact, I would advocate for working in agile even as much pre-production as you can. And the reason for that is I think agile just philosophically focuses more on how do we get this thing to a workable state and then iterate on it, right? Rather than, you know, the obvious corollary waterfall where you're just trying to get it right the first time and, you know, blah, 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 step by step. I certainly have seen agile work quite well during my time at Fitbit and now Google. I think it helps to think about how you're developing in terms of, hey, how do we get something working end to end, and how do we start measuring that and starting to iterate on it. I think, yes, there are parts of your schedule and your development that are going to need to be waterfall. I mean, hardware tends to work that way in general, but you know, the more that you can sort of front load that development and make sure that you're able to test it once that hardware comes in or once that module has landed, I think Agile has a lot of great benefits in that respect.
Yeah. Anybody have anything else to add to that?
I agree.
Great.
Apart from as long as it's not, I think, you know, hardware does still have implications. You're shipping stuff into the real world, and it shouldn't be the excuse to allow quality gates to slip, right? That it can go the other way. It's like, oh, we'll you know, treat it too much like software. So yeah, it's a balanced thing, but yeah, in general, I would totally agree.
Got it. Going back to Andy real quick, when you were talking about audio dropouts, how is that stat being measured? Like, how should people think about that? Is that a counter, or is that just a simple count, or are they doing something really complex?
Great question. No, that is just a simple counter on devices out in the field and pre-production as well. And you want to be able to look at the count, ideally over time with a serial number, so that you can see overall sort of like number of audio. The way that we actually sort of try to normalize it, because it's important to try to normalize these things for your fleet size, is number of audio dropouts per basically minutes or hours of listening sessions, right? So you can see the percentage across your fleet pretty clearly there.
Metrics don't have to be complex. In other words, just literally count the number of times something happens, and if that number goes up or down on the average, you have yourself a trend and you can figure it out. One of the things that combining a lot of topics here, probably dog fooding, internal testing, shipping new releases, agile development. Think about it. The more you ship and the more you test internally and look at that number, the quicker you'll find where the regression took place. One of the problems that we've had in the past is when we would ship firmware and it would be a 3-month between firmware updates and there was a regression somewhere in one of our metrics, it was 3 months of commits that we had to churn through to figure out where the regression took place. If we shipped every week internally and got enough data, we would know, oh, this week-long commit history is where the bug basically lived. And then you can use Shiva's post about git bisect to find out where the actual issue lies. But totally different conversation.
No, just picking up on what you said about simplicity, Simon talked about using the same core KPI up and down and across like all of the organization. If you're overcomplicating your metrics or what you're collecting, it's going to be difficult for not just your teammates to understand. Like, a big problem in data is like, what does this mean? What is this metric? I don't understand. Like keeping it as simple and obvious and well noted and documented as possible, so that when it lands on the CEO's desk or the CTO, often we have a lot of customers where the CEO is like, has a device in their house or something like that. Like, that one can't fail. When it goes across their desk, they need to be able to simply understand what this means, even if they're not deeply involved in the firmware, right? They just need to know good, bad, count, great, done.
Yep. I have an interesting question here. It's a slight bit of a tangent from today's topic, but can be related. OTA. When you ship an OTA, should it require user intervention? Should they have to accept the OTA, or should it be automatically updated? I guess, what is best practice, whether it's B2C or B2B? And this is probably for Simon or Shiva.
Yeah, I mean, I think you're right. Probably consumer versus industrial is different. I mean, it does depend on the scenario, right? But I think the way I'd be looking at it is, how do you minimize disruption regardless? So the difference of like downloading, understanding that the firmware needs to be updated, downloading it in the background, such that actually an application cycle can be much shorter. The risk of that device or the risk of that device not performing its function if something goes wrong, is much lower. So the idea of being able to inbound download firmware, dual bank it, etc., rather than blowing away and then sort of reinserting firmware. There are those sort of basic things that just mean that the experience and the downtime can be minimized, right? But then I think it really comes into the domain, right? I mean, if you can apply it, if you understand the life cycle of your device and how it operates, and you can apply it without user intervention, I think in a lot of scenarios that's exactly the right thing to do, and a lot of companies do that because in some sense it's not the customer's problem. They don't even care. So to teach them to, again, this is a cost thing, right? To train them that there is such a thing as a firmware update and they must intervene and it's potentially a huge cost, right? But yeah, in other scenarios, it's exactly the right thing to do. If it's a much more consumer device with a screen, it's pretty, I think then it becomes down to usability trade-offs and decisions like that.
Yeah.
But yeah,
Plus
yeah.
The other thing I'd mention is it's very useful once you can get that sort of workflow going, because I can't tell you how many times we've had, we've looked at our graph and we're like, well, 10% of our users are still on 3 firmwares ago. And they're the ones that seem to be calling the most because there were some pretty big problems with that one. And, then your company's paying the cost of customer support call just to have someone say, hey, see that big pink banner saying firmware update me? Press it, you know? So there's definitely a lot of benefits to being able to, roll things out in a way that doesn't interrupt the user and keeps the experience good.
Yeah, some customers will just choose to never update their devices if they have a choice, which is a cost for everybody. I have a quick question here about that internal development board, basically, that we talked about. It's kind of like 2 products. You're building for an internal development board and you're building for production. Are they the same board? Or is it the same firmware? Is it completely different? Like, what have you guys done? What's best practice there if you guys are doing multiple revs? I know Shiva, I fit that our boards were maybe like a foot by like 8 inches. I brought like a pizza box in my backpack basically to carry one of these things around.
Yeah, I think you want them at least as close as possible, right? Hardware development happens. Sometimes you don't get it right the first time, and you have to, make changes and different configs in your firmware to be able to handle that. But I think the key concept there is, if at all possible, they should be the same, and what you're developing on should match what is going to go into production. And if it's not, you should figure out why and characterize it as soon as possible, and ideally bring the two, like the dev and production device, together as much as you can.
Yeah, agreed. I think we were able to run most of the same firmware at Pebble. I think maybe the display wouldn't work because we had basically changed the rev on that, but like almost everything else would work exactly, and it was really nice. But they were pretty much the same
And if
board.
you can
And
make
it
it
was,
so that you can, even upgrade that board with just like a little adapter, then your problems significantly decrease.
yeah, for sure.
I guess the other thing is making sure that the same firmware runs on both boards, despite the fact they're different. Often that's something, rather than a forked code base and very simple stuff, but actually adding the logic into the application such that it runs on both feels like an overhead. Surely, it's only going to ship there, but actually, when you're talking about the agile process and things like that, or different people working with the same firmware and different things, if you anywhere there's a chance to unify something, I would say go for it.
Mm-hmm. I'm going to try to tackle a couple of birds with one stone here, and then I'm going to wrap up the conversation. What's the best practices for testing before shipping a firmware update to your customers? So we've talked about dog fooding. Make sure you're dog fooding your products and making sure that like your internal users and maybe a beta cohort is actually using the product, but that doesn't force all edge cases. So what's the best practice for testing, I guess, your firmwares before deploying?
I don't think it differs that much from launching, right? You want to be measuring the same things. Obviously, if there's something specific that you're targeting in with that release, you should be checking that one out. I think the biggest thing that we see in OTA deployments is that you focused over here and you fixed this aspect, but now you've created a problem somewhere else. And that's where it's really important to continuously test against those like core KPIs that you're looking at as well. And I think especially rolling out with, while you're rolling out the OTA release, doing a slow and staged rollout. Maybe go first, have like a beta friends and family friendly cohort that you're rolling it out to first, and then slowly watching it progress until you get to, whatever your entire fleet size may be. And applying the same strategies, right? Like look at the high level indicators and then drill down where if there's any problems, and be able to have that, like, are we improving? You should be improving, right? Going up on every release. Hopefully that's the goal. And And if you're not, you can have a clear indication, hey, we need to pause the rollout. We need to do more investigations, and start re-looking at that code before it goes out to the entire fleet.
Shiva, can you talk a little bit about, hardware in the loop testing, unit testing, QA, CI? I guess what is realistic for a company, and what should they aspire to do, and maybe in what order?
Yeah, absolutely. I mean, to me, unit testing is the table stakes beginning, right? If you're writing code, you should be writing unit tests for it and making sure that you have all the infrastructure around that, because I feel like that's the low-hanging fruit that will catch a lot of your bugs in the first place. Now, when it comes to hardware in the loop testing, there's a lot more discussion that tends to happen because A, you're spending extra money on hardware. B, the tests that you do take time, and you have to make sure that they're absolutely stable and that they're not flaky. Additionally, you want to make sure that those tests are being run at appropriate intervals. So as one example, we had some hardware in the loop testing at Fitbit that was testing the eMMC storage device on basically every single run of a pull request CI. And lo and behold, that tended to wear out the flash very quickly. And so, trying to balance that sort of thing in terms of, am I actually going to exponentially increase how much I'm spending on hardware because I'm wearing it out so quickly because of my testing versus not, is also something to consider. I think having hardware in the loop is really important when you're actually needing to test the hardware itself, which might seem obvious, but since it tends to take time and there's a lot of infrastructure to get right in terms of flashing it and making it not flaky, it's very useful to consider what's actually useful to do with hardware versus what you might be able to do with more of, say, unit tests or even emulators.
Yeah, great points. There's extensively testing the hardware is not the same as extensively testing the software. And of course you need to do both, but that's maybe where dog fooding or like QA comes in handy for the most part. Simon, have anything to add there? And if not, we'll wrap it up.
No, I mean, I think, yeah, if emulation and things like that are so powerful now, there's a lot you can do in very tight circles. But I'm still a big believer in hardware in the loop, especially for spotting regression and when things are behaving with real radios and things like that. So even if that's manifesting in the device not going to sleep, in just the real life behavior, exposing timing that you wouldn't get in a totally repeatable emulator. Yeah, I mean, it's great, and I think I hope it's much more accessible to do that now than it was, say, 10 years ago. So I would expect it to be part of most people's recipe. But I think as Shiva said, don't rely on it overly, because you could burn a lot of time using it for where a software solution would be just appropriate and way quicker and much more scalable.
Yeah. All right. Shiva, Simon, Andy, thank you all for joining. I had a blast. Thank you for the good conversation, the good questions. I guess the disagreeing opinions every now and then, for taking the time. If any of the attendees still, you want to reach out to these folks, you have their now LinkedIn information. You can probably find their emails online as well. Reach out to them. We'd love to chat. And thank you all.
Excellent.
Thank you.
Thanks very much. Looking forward to the increasing quality of products we're going to see.
Absolutely.